Alright, for this video we're going to look at a couple of quadratic equations set equal to 0 already for us, and we're going to look at completing the square. And completing the square on the left for this 3x squared plus 4x minus 2 equal to 0 will be pretty tough already, just because we're going to have some fractions to deal with. We're going to have to factor that a value at some point. And then the ax squared plus bx plus c will be even more complicated because we don't actually know what these numbers are. But we're going to do the same steps back and forth to kind of show you what the answer would look like, even if we didn't have any idea what a, b, and c were. So starting out on the left, the first step for completing the square is to move the constant or the c value over, no matter what. Even though I see this 3 and I know I'm going to have to factor it out because completing the square only works with an a value of positive 1, I still need to move the 2 over first. So I'm going to add the 2 to the other side. So it becomes a positive 2, but I'm also going to leave a blank where that 2 was. And I'm going to put a blank beside the 2 on the other side too, because to complete the square, I'm going to eventually add something to both of those sides to make it something that's a perfect square binomial that I can factor. So on the other side, I'm going to do the same thing. Even though I have no idea what c is, I'm still going to move it over. So I'm going to leave ax squared plus bx, and I'm going to leave a space. And even though I have no idea what plus c is, it might be a negative, I'm still going to show that I subtracted it to the other side. So minus c, also with the blank. Okay, so for completing the square when the a value is 1, those are a lot easier because you can jump straight to the cutting the b value in half, squaring it, and add it to both sides. But when you have an a value other than positive 1, that has to be factored out from every term on the left side. We're going to leave the 2 alone on the left, but I'm going to factor out the 3. And even though it doesn't go evenly into 4, I still have to show its division, otherwise this parentheses wouldn't work. So plus 4 divided by 3, and I'm going to leave it as 4/3. Don't want to change it to a decimal. Still with a parentheses here, with a blank. Same thing with a blank on the other side. Now for the ax squared plus bx on the other side, same thing. A might be 1, but just in case, I have to show that it's factored out just to show the correct step. So I'm going to factor the a out. And just like with the 4/3, I have to divide whatever b is by a as well. So plus b over a to show I factored that a value from the b value. Still equal to the negative c with a blank. Alright, so we are finally to the point where you can complete the square now. So the way you complete the square is that you take the linear coefficient, the b value, you cut it in half, and then you square it, and that's what you're going to add in the blank for both sides. So 4/3 has to be divided by 2 or cut in half, and the result has to be squared. So whatever that comes out to, that's what I'm going to add to both sides. So we can cross simplify a little bit here. 4 over 2 would simplify to 2/3. So 2/3 squared is what I'm going to add in that first blank. So 2 squared is 4, 3 squared is 9. I'm going to add 4/9. Now another thing that's tricky about when you have to factor out an a value when it's something other than 1 is that when I add to the other side, I'm not just adding 4/9. I have to add whatever 4/9 times 3 is, because that's what's happening on the other side. Everything in that parentheses is multiplied by 3, so I have to do the same thing so I can keep this equation, which is basically like a scale balance. So 3 can simplify with a 9 over here, so that would simplify to 4/3. So that's what I'll be adding to both sides. Now, on the other side, even with the one on the left, it got complicated because we're dealing with some fractions. It can still look complicated over here as well because we still have to follow the same process. I have to take this b value, this b over a, or the linear coefficient. I have to cut it in half and then square it. So nothing simplifies here. That's b over 2a squared, and that's what I have to add to both sides. So b squared over 2a both squared would be 4a squared. So that's what I'm going to add in the blank on the left side. But just like we had to apply this 3 on the left side, I have to apply this a value, even though still I have no idea what it is. But if I'm going to add b squared over 4a squared to the left side that's been multiplied by the a, I have to do the same thing over here. So we can cross simplify a little bit. This a value can cancel one of these a values, so we're just left with b squared over 4a. Okay, so we're getting close to finishing now, and now we can finally show the point of trying to complete the square here, because we can factor this trinomial to something that's x plus or minus squared, so we can eventually isolate that and solve from there. So a trick with completing the square that works whether you have fractions or not, is you can use the value you got when you cut it in half as what this is going to factor to. So if you're really good at fractions, you can say what multiplies to be 4/9 and adds to be 4/3 and factor this the same way you'd normally do with a quadratic trinomial. But if you want to save some time, it's always this number before you square it. So plus 2/3, and that saves me from having to figure out what two numbers multiply to be 4/9 and add to be the 4/3. And on the right side, I have to do a little bit of fraction work because I'm doing a whole number plus 4/3. So 2 with a denominator of 3 would be 6/3. So this is 6/3 plus 4/3, or 10/3. So we're almost to the point where we can solve over there. But let's jump back to the other side and finish on the right. So same trick I'm going to use. The a stays in front. And as difficult as it would have been to figure out what numbers multiply to be 4/9 and add to be 4/3 on the left side, it'd probably be even tougher to try to figure out this over here, to say what multiplies to be b squared over 4a squared, but also adds to be b over a. So I'm going to use the trick. It's always the number before you square. So x plus b over 2a equal to, and another complicated part of this is I have to add negative c plus b squared over 4a, and that means I need a common denominator. So I'm going to multiply this negative c over understood 1 by 4a on top and bottom. So that's negative 4ac plus b squared, and now it finally has that common denominator of 4a. Okay, so we are getting to the point where we can finally start solving. So I'm going to isolate the x plus or minus the number squared, and then I'll solve from there. So on the left, I'm going to multiply both sides by 1/3. And you can think of it as dividing by 3, but since I have to apply it to the 10/3 on the other side, I decided to change it to multiplying by 1/3 instead, just to make my life a little easier. So these 3's will cancel out. I'm left with x plus 2/3 squared equal to 10/3 times 1/3, or 10/9. Okay, so on this other side, same thing. Before I try to take the square root, which I'm going to do on the left when I come back to this one, I have to get rid of this a value first. And same thing, I could think of it as dividing by a, but since this is a fraction over here, I'm going to think of it as multiplying by 1 over a, which is the same thing as dividing by a. Okay, so over here, a will cancel a, just like it did on the left when it was 3 over 3, and I'm left with x plus b over 2a squared equal to negative 4ac plus b squared over 4 times a, or 4a squared. All right, so on the left, we are getting close to finishing. Now we can take the square root of both sides. So I'm left with x plus 2/3 equal to square root of a fraction is the square root of the top and the bottom. 10's not a perfect square, but I do need the plus minus. The square root of 9 on bottom is 3. And when I finish this, when I subtract the 2/3 over, since they already have a common denominator, it'd be really easy to write this as negative 2 plus or minus square root of 10 all divided by 3, just to make it a little neater. So that's as simplified as I can make it. When I finish on the other side, even though it looks a lot more complicated, when I take the square root, I'm going to do the same thing. That drops the squared, so I'm left with x plus b over 2a equals, I can't take the square root of this expression that's negative 4ac plus b squared because that's not a perfect square, and I'm going to switch the b squared and the negative 4ac just so I can get this negative out from the leading coefficient. So plus or minus the square root of b squared minus 4ac. And luckily on bottom, that is a perfect square. Square root of 4 and square root of a squared is 2a. And just like we did over here, when I subtract this when I subtract this negative b over 2a over, instead of leaving both over 2a, I can put the whole expression over 2a. So, as weird as it looks, hopefully now it looks a little more familiar. So the whole reason that random quadratic formula came around was because somebody decided to complete the square pretending they had no idea what these 3 values were. So whenever you see the quadratic formula, it's very easy to say this makes no sense. I have no idea why I'm plugging these random values into certain spots. It is a shortcut of completing the square. So now that you know where all these values come from, maybe it'll make the quadratic formula a little less painful.